Okay, once we've learned how to do mole stoichiometry or mole to mole ratios of the balanced equation, the next kind of problem are called limiting reagent problems with moles. This is pages 113 through 119, exercises 7F and 7G. A couple of things to remember as always. Limiting reagent, well, what does that mean? Reagent is just a special word for reactant, and the limiting reagent or the limiting reactant is the one that gets all used up, the one that limits the amount of product that can form. And it is your job to figure out which is the limiting reagent. And you can do that in the simplest way for these kinds of problems is to determine which amount of product is actually made, and it will always be a smaller amount. That's the way I like to do these kinds of problems. But your job is to know that you have to make the decision, okay? Now, how do you know when you have a limiting reagent problem? It's simple. The wording of the problem gives you some amount of both reactants in the problem, okay? So let's dive into one of these kinds of problems and work through it in full detail. There's our reaction. C6H12 plus O2 makes CO2 and H2O. The question is, if 7.7 moles of this stuff and 12.8 moles of that stuff react, how many moles of water will form? Well, you can't tell just by looking. We went over tricycle problems in class, and you know that you can't tell because the ratio might be different. So how do you find the ratio? You got to do that balanced equation first. Alright, so let's work through that fast. There's one of those. That means there would be 6 of those. If there's one of these, you would need 6 of those. That's 12 plus 6 makes 18 oxygens. That means that would be a 9. So notice that even though we have more moles of O2 than we have of this C6H12 stuff, we use up the oxygen 9 times as fast. So we have to do a reaction calculation for both of these to determine which amount of water will form. So the way I like to do these problems is I figure out, make the assumption that this one's a limiting reagent, find out how much product gets made, and then do the same calculation with this one and then pick. Alright? So that means that 7.7 moles of C6H12 or 12.8 moles of O2 will react completely. If we want to compare this to this, we do that mole-to-mole ratio thing. 6 moles of water per every 1 mole of the C6H12. Everything cancels here to give you 7.7 times 6. 46.2 is what my calculator says, since this is 2 sig figs and this is an infinite number of sig figs on the mole-to-mole ratio. We would say 46 moles of H2O possible. If all C6H12 reacts, right? If we assume that this is our limiting reagent, we could make 46 moles of H2O with 2 sig figs. The other possibility here is that the oxygen gets all used up. If it did, what would the ratio be? 6 moles of H2O will form per every 9 moles of O2 that react. 12.8 times 6 divided by 9 calculator here says 8.53333 repeating. Okay, how many sig figs here? Well, this has 3, this has infinite, so this answer would be 3, which means we're going to get 8.53 moles of H2O are possible if all the oxygen gas reacts. Okay, this part is just for you to be thinking about. You can't make both 46 moles of H2O and 8.53 moles of H2O. You can't do that. So you have to pick the smaller amount of product that forms. So it's up to you to figure out that this is the amount of product that forms, and the O2 is the limiting reagent. And this C6H12 is the excess reagent. All of the O2 will get used up here, and we'll have some of this left over. Now, they're not asking you anything about how much is left over. They just want to know how much of this actually forms. One last question. Should your final answer have 3 sig figs or 2 sig figs? After all, that number in this problem has 2, and that number has 3. How do you decide? Well, it's not the number of sig figs in the problem, remember? It's the number of sig figs in the calculation that gives you your answer. And since this is the calculation, this, think of it as like a test calculation that you decided not to use. If you use this one, the final answer has 3 sig figs. Key part to that. Okay? Great. That's limiting reagents. Do lots of practices on 7F and 7G, and you should get good at these. Be ready to identify this kind of problem because you have some amount of both reactants that you have to try to figure it out on your own. Okay? Have at it.